Welcome back to our series on Melange for React developers. This is the second video in this series. We're going to be covering Chapter 1, Counter. In our last video, we covered how to install the OCaml toolchain, get set up for this book. You can catch that at the link below. So in this video, we're going to be covering the Counter chapter. So let's read about that. So the summary of the chapter is we're going to build an app that can be incremented or decremented, and we're going to learn about modules, the option type, we're going to learn about react.string, the pipe last operator, function chaining, and switch expressions. So without further ado, let's jump into Counter. We're going to build the classic front-end starter app, the Counter, using Reason React. If you've already installed the starter project, you can run the project now. Go to the root directory of your Melange for React devs template project and run npm watch to start the Melange compiler in watch mode. In another terminal window, start the Vite dev server by running npm run serve. As a side effect, it will open a browser tab. So the reason we want to do this is npm run watch is going to run OCaml's build tool Dune in one process, and that's going to watch our OCaml and Reason ML files for changes. And then npm run serve is going to run our JavaScript dev server. So the flow of code here is we're going to go and edit our OCaml and Reason ML files. Behind the covers, Dune in watch mode is going to see changes to that, and then it's going to use Melange to compile our Melange and OCaml and Reason code to JavaScript. Then Vite will see that JavaScript was compiled and changed, and then we'll refresh our dev server. So let's run both of these. So we're going to make a new window here, and let's decrease the size. In the first window, we're going to run npm. Actually, we need to get a Nix shell here. So now we should have node. Perfect. So let's say npm run watch. Okay, cool. Dune is now watching for file system changes. And let's open our second dev server, and we're going to run. We have to load up our dependencies. Great. npm run serve. Now this should open a browser. Yep. Okay, so we have a simple web app here. Let's jump back to the instructions. Open index.re and you'll see this code. Module app equals this React component thing with a function called make that returns a div and a React string that says welcome to my app. This is just about the simplest component you can make, but through it we can start to see some of the key differences of developing with Reason React. All components must be inside a module. The make function renders the component and returns a React element. We must decorate the make function with the React component attribute. In JSX, we must wrap strings with calls to react.string. Let's go over these differences in more detail. Components are modules. In the example above, a new module named app is defined. OCaml's modules are somewhat like JavaScript modules, with one notable difference being that there can be multiple modules inside a single file. For now, you just need to know that all components in Reason React are modules, and the name of the component comes from the name of the module. The make function. The make function has a function signature type of unit to react.element, meaning it takes parens, aka the unit, as the only argument and returns an object of type react.element. You'll need to decorate make with the attribute at react.component. We'll go into the details later, but for now, let's just say that React component is there to reduce boilerplate and make our code more readable and easier to understand. Wrapping strings with react.string. Unlike in normal React, we must wrap strings inside function calls to convert them to react.element type. This is exactly what react.string function does. If you hover it over it, you'll see that it displays the type string to react element. Using the app component. A little bit further down, we make use of the app component. We have let node is react dom.querySelector for the root, and then we're going to pattern match on node. If we get no value, we're going to log to the JS console, failed to start React, couldn't find the root element. if we do find the React root or the DOM root, we're going to say root equals react dom.client.create root, react dom.client render that root our app. So this should feel very similar to how we bootstrap our React apps in TypeScript and JavaScript. React.query select a root returns a option DOM element, meaning that if it doesn't find the element, it returns none. And if it does find the element, it returns some DOM element. That is the element wrapped in the sum constructor. The switch expression allows you to succinctly express if node is none, log an error message. Otherwise, if node is some DOM element, render the app component to the DOM. We'll talk more about the option in the Celsius converter chapter. The counter component. Let's create a counter component by creating a new file, counter.re, with the following contents. So let's go make that file. So let's launch into Vim and we'll say counter.re. We'll save that, make the file, go into there. Let's go grab the code, copy to clipboard, paste that in and save. Okay. This is a component with a single use state hook. It should look fairly familiar if you know about hooks in React. Note that we didn't need to manually define a module for counter because all of the source files in OCaml are automatically modules, with the name of the module being the same as the name of the file. Now, let's modify app so that it uses our new counter component. So let's go to app. And in here, app, instead of rendering this v1, we are going to instead, change this, and we are going to render our counter. We'll save that, jump back to our instructions. Okay, that looks good. The pipe last operator. To display the number of the counter, we wrote React string and passed int toString of the counter value, which converts an integer to a string and then converts that string to a React element. In OCaml, there's a way to apply a sequence of operations over some data so that it can be read from left to right. This uses the pipe last operator, which is useful for chaining functional calls. So we're going to take counter, we're going to pipe that into string. So this will turn our integer value to a string, and then we will take that string value and pipe it into React string. So let's jump in here and let's go back to our counter component. And in here, oh, right here's the part we need to change. So we are going to change this to instead be counter, which is an integer, and we're going to pipe that into int.toString, and then we'll pipe that into React.string. And we can now delete that bit there, and that should be completely equivalent. Great. Let's add a bit of styling to the root element of counter. Okay, unlike in React, the style prop in Reason React doesn't take a generic object. Instead, it takes an object of type React dom.style that is created by calling React dom.style.make. This isn't a sustainable way to style our app. Later, we'll see how to style using CSS classes. So let's copy this div and replace our div. So we'll come up here and we'll take this and we'll replace it, and we can format. Cool. So we're going to add some padding, we're going to make it flex, and we're going to give it a gap of 1em. Awesome. Jumping back over. Congratulations, you've created your first Reason React app and component. In future chapters, we'll create more complex and interesting components. Let's actually see how this runs in our browser, because this should be in our browser if I am not mistaken. What was our port? We're on port 5173, so let's open that and see what our app looks like. Okay, so here's our app, and look at that, chat. We've got a working counter. So here was the overview of what we covered in this video and chapter: how to create and run a basic Reason React app. Reason React components are also modules. OCaml has an option type whose value can be either none or some value. The pipe last operator is an alternative way to invoke functions that enables easy chaining of function calls. And we also learned how to use styles in Reason React. So what happens if you try to remove the none branch of the switch node expression in index.re? Well, my prediction is that we will get a type error. So let's go try that. Over here, and if we remove this, yep, error warning. This pattern matching is not exhaustive. Here's an example of a case that is not matched none. Cool. So OCaml's and Reason ML's type system is going to enforce when we do pattern matching that we cover all of the possible cases that a value can be. So let's jump back to our exercises. Removing the none variance will result in a compilation error. Basically, the compiler is telling you to handle the none case if you want to ship your app. This is part of what makes OCaml such a type-safe language. Exercise 2. What happens if you rename the event variable inside the button callback to event? Well, I'm going to guess that we're going to get a warning about a unused variable. So let's remove that. Yep, unused variable EVT. And let's add that back in. Let's look at the solution. By default, OCaml wants you to use all the variables you declare unless they begin with underscore. So that should feel very familiar if you're coming from TypeScript, JavaScript, and React. Comment out the React component attribute in counter.re. What happens? Ooh. I believe we will probably get some type errors somewhere. Did that say in the counter? Yes. So let's go comment this out. So far nothing. Let's see our console output. Here we go. Unbound variable counter.makeProps. So what this is really doing for us when we put this annotation on it is it's saying, hey, Melange, when you compile my code, I want you to take this make function and add additional code to it at compilation time to make this a proper React component. So let's see what the author says about this. Commenting out the React component attribute in our counter.re will trigger a compilation error in index.re at the place where counter component was used. Yep. For now, don't worry about what counter.makeProps is or where it came from. Just remember that you need the React component attribute above your make function if you want your component to be usable in JSX. This is a very common newbie mistake. See the PPX chapter for more details.